Hey, and welcome to Python on Android. Disclaimers first. My name is Bodemann. I work at Yubico. We are doing YubiKeys. This talk is almost unrelated, except for also at YubiKey. We are sometimes using Python as languages. But I am an Android developer by heart and found out that there are some things that are existing on Android and that there are other things that are existing on Python, and I want to combine those two worlds. Outside of this one, please feel free to ask me the security questions, how to use a YubiKey. If you don't have a YubiKey yet and want to have one, feel free to talk to me afterwards. Also, if you are into sewing, like you like to do your own clothes or fabric or something, feel free to talk to me afterwards either. Also, if you have any other topic you want to talk about, let's. Okay, so let's go by Python. Hands up who has done anything with Python before. Well, that's all of you, perfect. And now same hands up for who has done something with Android before. Oh, okay, that is nice. So like the most introductory talks will be very boring for you. I'm sorry, but you know, there might be audience members on the videos who haven't done anything in Python or Android yet. Okay, Python, great language, has a snake as a symbol. What else do you want, right? Well, maybe you want to have a language that makes sense. You know, like for me, it has the least what the per minutes. So I just, you know, I can see it, I can read it, I can understand what's happening. I'm ignoring spaces and tabs for now. Also, it runs everywhere where most of my apps are running, right? It runs on Linux, it runs on Mac, it runs on Windows, it runs on Android. I'm ignoring iOS for now. And another nice thing, there's no compiler involved at the first step. I just say Python run, and it runs. It does compilation in the end so that it's like faster also when you're executing it, but we will not go through those details for now. Down in the box in the slides, you see Python code, right? It defines a function called hello with a parameter called name. And the line afterwards is just printing out a string, and the nice thing is that this string contains the variable, so it like does string interpolation out of the box by just using f in front of the string. Again, we have Python devs in the room, nothing new for you, but for me it was interesting that also something like executing the function and putting in the input from the user is as easy as calling the input function, which is the last line of the code snippet you see on the slide. So now if I'm executing this code snippet, you see like what you would expect, right? It is asking me like, what is my name? And I'm saying my name is DevFest. It's obviously not my name, right? My name is Bodemann, but for the sake of an argument, I now hit enter, and you see that it parses the input I gave it and printed out hello world, my name. Great, Python works, who would have thought? But it does also a bit more in the sense of more complex things. So if you are into scientific data processing, you probably use Python for augmenting your data, sorting things, or using the Wiener transformation. I don't know what it is, I am not a scientist, but for instance, this is code, don't go into the details here unless you really, really want to. This is just for showing that you can also execute something random on Android, on Python. That's a bit more complicated than you would expect. So for the scientists in the room and outside, this is obviously how the Wiener transformation works on random data. If you know what it is, please talk to me afterwards. And also if we are taking a look at the code I was just executing, like it makes sense. It's like nothing very surprising, and I really like that one. I like it so much that except for my Android development, which is mostly using Kotlin, I decided to have my dot files, my scripts I need for development running in Python. Like everything I need to do is done by a Python script. And what is this in concrete is I need to have rainbow colored boxes around texts from time to time. I also need sometimes that my text, input text, is translated into a different font or a different UTF-8 character. Or the most important thing is if I'm having a Slack message, I want to express it as Slack emojis. So therefore, I wrote a Python script called Fraktur. And if I'm executing those scripts now, you hopefully see that it created from the welcome input string 3 different representations. It made a beautiful rainbow border surrounding it. It translated characters into chess symbols because who doesn't need that one? And most importantly, it used the emojis from Slack in order to represent the welcome. So I could use this one now to just type into my laptop, hey, Fraktur, please give me the Slack emojis for new release build or something. And then I take this, post it into Slack, and my teammates now know with fancy colors, hey, there's a new release. But there is one problem, which is now here for dramatic effect, that this only runs on my machine, right? What happens if you are on the go and you say like, hey, I need to tell this my friends in a specific formatted way. I want to have the Python script I wrote running on Android. I want to be able to write an Android app or have Android UI that uses this script and just, gives me the results so that I can use it on my Android ecosystem. So I found 3 ways how this would work, and I'm just going to walk you through them one by one. The first one is using an app called Termux. Termux is an Android app that is actually a terminal inside your Android environment. So what I'm doing with the slides here, or whatever you want to do in a Linux environment, you can do on your Android phone by just typing words into it, and it executes it like a terminal would. Ideally, you install this through an app called F-Droid, which is an open source Android application ecosystem. It's like the Play Store, but outside of Google, which only features open source apps. You can run, obviously then, after you do have installed it in F-Droid, you can run this app, you have a terminal, and inside the terminal you can install other apps as you would on Linux or on Mac. And Python is one of those apps, right? So I can use Termux to actually install my Fraktur script and then ask Termux through Termux GUI and Termux API to execute code that shows Android native UI. So I have Termux, I have Python inside, and with Termux GUI and Termux API, I can have access to everything the Android phone offers to me. Like you can send SMS if you like to, you can send a clipboard, you can update your clipboard, or you can take a picture by just using terminal commands. Okay, that's one part of the equation, but let's see how we are actually doing this one. So for that one, I just decided to make a random live demo. And for that one, I'm starting my emulator. Don't worry about the details seeing on screen. This is just starting the emulator, hopefully successfully. Just don't have too much going on at the same time. We are having this one. And I want to show you like just Termux in action. I hope this will be readable at this in a second. If not, we can always try to make it a bit bigger. Okay, perfect. So this is Android emulator. Imagine it's also running on your phone the same way. There is no difference so far. So Termux looks like a terminal. So I can just open this one, and I'm just going to call reset because there's too much data going on. But this is what you expect a terminal to be like, right? You have your prompt. You can do an ls. You see that there are files in there. I don't know if I have Causa installed. No, I don't. I could probably just install it by using pkg, which is the package manager here. Obviously going off script right now, seeing if this works. And if I see some green text, it's great. Otherwise, you see that this is the normal Linux experience. Sometimes it works, sometimes it doesn't. So what I'm doing currently is I'm just installing another app inside Termux, which is an app in my Android phone. I'm seeing some OKs, so I'm feeling good about it. And obviously, I want to do more changes to my running app. It's going to be great. And now I'm back here, right? So I have my prompt again. I installed hopefully something called Kausei. And if you know Linux, you know what it says. Hello world. Ta-da, I have a cow saying hello world. Isn't that already amazing enough for you to be part of this talk right now? But let's go back to the slides, right? So like I also wanted to show how you can not only use the terminal to do terminal things, but also interact with the Android environment. So the easiest one is all commands in Termux interacting with Android start with Termux hyphen. So I type Termux hyphen, and then for instance, there's something called dialog, which will hopefully open a dialog. I'm giving it the parameter -t because I want to give it the title of DevFest. Ta-da, I have now an Android UI-ish popping up based on what I typed in my terminal. Well, that is already something. Don't mind those parts here, except for whenever I'm typing something useful here, like 2025, and hit OK, I get JSON back from the terminal command I just called. So what does this mean? I have input and output to Android UI using a terminal. Great. OK, that's that. But I also said that we can use Python in there, right? So if I'm just copying the snippet here, I can go back to my terminal in the Android emulator and actually open Python. And this is the default Python prompt you see down in the end of it. It's calling Python 3.12 right now because of reasons, but I could probably do random Python things. Like I can obviously print hello world, as we all should. Print hello world. But so far, not really helpful. But what I want is to use Python to call into native Android UI, right? And how I would do this is by using a Python tool or a Python library that is actually called subprocess. With subprocess, I can call different processes, different CLI installed applications. And if you follow the script on the slides, you see that I can call Termux dialog, the app I used before, directly in this in Termux to just display anything I want powered by Python. And in order to show that it's true, I have, again, my Python open. The script we are seeing on the slides is in the paste buffer. I paste it. It's executed on Python, opening a native UI in Android. Hooray. And I can like just continue doing the same thing here, right? If I now put in 2025, I get the response in Python and can deal with it afterwards. Okay, so who remembers why we are already doing this one? What is the actual purpose of this part of the talk? Why do I want to do that?
Text with rainbow?
Text with rainbow, exactly, yes. that is perfect, thank you. Because this is now all the pieces I need, right? So like I have Python on Android. I have a way to show native Android things. I also have done the part of already installing my library in Termux, which is the part you're seeing in this snippet here, where I'm just saying the library is under this specific path. Once I have this one, I can call it with import Fraktur. This means like, please use my Fraktur library. And then I call it with just Fraktur.generate with the input text. Or in this case, it's a static text. I just want to see if the integration actually works. So I'm going back to my emulator. And in this case, I'm just going to paste and see what happens. So, okay. This means probably not a lot for you, but what I'm seeing is a lot of text, right? I'm also seeing like : alpha W white or things. So this looks like a Slack translation. And since my scrolling is not perfect, there we go. We have hello dev fest world in something that is not classic ASCII. So we can assume, based on the slide snippets we were seeing here, that hello dev fest world was taken, translated through the library, and then outputted into something we can then use in Python. Great. Well, now we actually want to also use not only the Python runtime, but we do still want to use the Python runtime, but we want to make it dynamic, right? We want to have interaction in there. How would that work? Well, the answer is, again, we are calling the Termux dialog to ask the user questions. So in this case, again, we are using subprocess here in Python to call Termux native applications. And there is an option called sheet. And the sheet takes, again, the t parameter, which in this case is just called factorize. I'm not sure if it's English, but I'm gonna go with it. But also takes the option for -v and then a list of options, right? So like in this case, if it's comma separated, the options will be displayed as a bottom sheet natively on Android so that I can select from it. In order to select it, I need to tell also the subprocess to capture the input and output, right? If it wouldn't be stated there, it would just like forget everything that we are putting onto the command line or receiving from it. And so once we have now called this Termux give me a bottom sheet with all of the options, we can process the output by just using process.stdout.decode. And again, the decode is because we're getting a byte string back and we can't really pass a byte string in this case, so we just wanted to have the string. That's why we have the decode at the end of it. Okay, one step further. Now that we have the response, we need to path it once more, right? We need to now find what did the user actually click on. So the output from the Termux dialog we just saw contains the JSON that tells us what did the user select. Now we take this one, parse it, and then from the parsed result, we take the text and put this into the clipboard. We're getting somewhere, I hope. Let's just like try and see if I can put this into use. I forgot how my slides currently work, so this all assumed that everything worked once together. Let's go one more further and see where we're ending up. So like, yeah, okay, this was the summary I was just doing liberally while freeloading what I wanted to talk about. Okay, so like we see that this is a way that it would work, right? We have Python, we have Fraktur, the library, we can all put it together in Termux. The problem is that the UI we were just seeing is very limited. Like it has options, yes, it's great for input for basic things. It's very, very nice. But what if the Android developer in me comes through? What if I say I want to design the UI myself? What options do I have to have a native Android app that talks to Python without having Termux doing the Android discussions for me? Well, this step is called we are going for a web app. So in Python now, we are building with Flask a website that runs on the localhost, and then have the Android app connecting to localhost so that the Android app can ask the localhost, please give me the messages. The localhost Flask Python app is translating the message into whatever the output of Fraktur is. You see where I'm going with this one. Introduction to Flask real quickly. That's a micro web framework where you can easily just define a web server that is running on the Python environment. And in this case, it's on the Android phone. You install it like you would because you have a terminal involved. You can just say pip install Flask, and this installs Flask into your Termux environment, which I have done. I don't need to do it right now in the environment right now. So how would you build a server in Flask? Well, you import the library. In this case, I rename it from capital Flask to lowercase Flask, very important. and then call that creation with giving it a name called Fraktur server. Once I have the app, I can actually augment it and say, hey, whenever the server gets called on the / endpoint and it is a post, please execute the code that is following on the next slide. And once we have the route defined, we can say, now please server start by calling app.run. This will start the server on port 5000 on the local machine, and we can execute it. But then the question is, what actually happens when we invoke the /? What happens if we ask for the route of the server? Well, this is the body of the message I was just talking about. So we take whatever data object we got in the request from the client on our web server, and then we call our Fraktur library to just translate it into whatever the Fraktur library does with its input. And then we return it, not split by /ns, but by comma. That's what this one does. And in order to prove what I'm talking about is I'm going to run this. So don't worry about the messages. Here, I'm just going to exit out of Python in the library, in the emulator. And now I'm going to create a server.py. This server.py contains now the server code I was just describing, especially when I'm pasting it. So it's exactly what we are just having in the slides, right? So this is now the server Python code. I can access out of Vim because I forgot that escape doesn't work here. So if you want to exit out of Vim, you hit escape and then W. Q. Now that I exited out of Vim successfully, I can now run the Python scripts by just calling Python server.py. You see red? Don't be alarmed. It's just saying, hey, this is development code. Don't do this in production. It's fine. We might not be doing this in production. But what does this mean is I have now a server running on localhost. Well, who believes me? Very trusting, I like this, but again, data is the source of all, right? So let's find out if this is actually true. So, and if we want to find out, I now open another session on Termux, which I use to use Termux as a client for the local web server. And in order to test whether a server exists, I use a tool called curl. And so curl is already installed in my terminal. I just say curl localhost 5000 with the data of the message I want to translate. Give me a good message.
Hello cow.
Hello cow, perfect. I do another thing by piping it through JQ just so that we have it colorful. And you see, we have now, what does this do, right? So I called my web server running on my terminal that provides me the ability to call my Fraktur Python library on Android. Hooray! But where's the native UI? Right? Okay, now I can ask my client, yeah, you just go into the terminal, use curl, and you... This is not what we want, right? We want to make it as easy as possible for the user. So we now write an Android app. Welcome to the other side of things. Welcome to Kotlin. There will be no big surprises here because it is an Android app, right? We are using default settings, like things I would recommend people to start with when they're starting with Android. It's an MVVM, it uses retrofit, it uses Kotlin X serialization, and it uses coroutines for parallelization. I'm going to show you some more code samples for it, but the purpose here is replacing curl from the terminal with a native app. Like I said, I'm going to use retrofit. So like in order to externalize the service into our Android ecosystem, I have to define the interface first. Like what do I expect as an Android app the server looks like and how do I communicate with it? In this case, I define this interface called Python service that exhibits a post REST endpoint just under the URL of /. I call this function getFractures inside the interface, and I expect that the body of this REST request is just a string. Again, that's our message, what we were using throughout the whole thing. And as a surprise to hopefully no one, it returns me a list of strings. So when I execute this one, I might get the right response. But this is just an interface. And since we're using retrofit, we also have to tell retrofit that they should build a service out of this interface. Well, that's the next slide in this case, where we are looking how we would build the Python backend. The Python backend creates with retrofit the service based on the interface I was just describing. And then it offers everybody who uses the Python backend a function called request fractures with a string that returns a list of strings. Again, just abstracted away so that we might be even able to replace it afterwards. So also this is a suspend function because we don't want to wait in case something with our local host is too late or whatever reasons we can come up with. Okay, so this is the backend. This is now the way how we would call it. And in order to call it, we have it as part as a view model. The view model has the backend as an internal variable, and we just say in the view model launch coroutines again whenever you have the time, execute it, but don't do it immediately if you don't have the time. Inside there, we just call the backend we described with the string we gave in from the user interface. Speaking of user interface, we use Kotlin Jetpack Compose here, right? So we have a lazy column, and inside we show all of the options the user might have selected based on the view model already having the Frakturen or not. And if somebody clicks on the card, we want it to be pasted into the clipboard so that we can use it in another app inside Android. And how does this work? And specifically, how do I use the clipboard manager? Well, it's a system service, so I get it through the context and then just define a clip data that has the context of the card I just clicked on and then say, this is the text I want to be in the clipboard. I hope so far this makes sense, but now I feel the excitement in the room. Does this actually work? Well, again, there is only one way to find out. I was a bit cheeky here, right? And said like, hey, I already have installed the app after I've built it. It has this beautiful green symbol because I didn't use Generate AI right now to just get the logo. It's the default. And as you can see, it has like text button, something I would expect from an Android UI. I click on it, the label moves up and down. Perfect, nice. That's how I want the app to look like. So, what should I type it?
Please work.
Please work, perfect. Maybe let's make it smaller. Now, if I hit this button, I translate it to the view model. The view model talks to the Python backend. The Python backend calls the retrofit service. The retrofit service translates it into a REST call that is captured by our server running inside terminal. And this terminal server is a Flask server that can execute Python code. It's calling into the library of Fract and then returns the whole way back and then hopefully displays something. Who thinks this is going to work? I love you guys. Thanks so much for your confidence. Yeah, please work. It did work. You can select whether you want it like not showing up at all, or it's a bit tiny. You know, I hope you can at least see the colors or the difference in font back there. But like you could take it now here. I click it on it, and it's pasted into my clipboard, and I can use it in all of the other apps installed. So far so good. We have native Android apps. We can now do both things, right? If I'm a native Python developer, I can have my fun playing around with it. If I'm a native Android developer, I can have my fun playing around with it. There is just, yeah, sure.
How would I deploy this app?
I like your question. That is exactly the point. Perfect. Thank you so much. Like, this is the summary here, right? So like, yes, our techie brain is happy. It works, but what about the user? Right? I want all of you to be able to execute this code, and I have to tell you, well, it's easy. First, you install F-Droid. Inside F-Droid, you install Termux. Inside Termux, you install Git, because you have to check out my Fraktur you know where I'm going with this one. It's like just not usable for users. For tech nerds who are using this on their own personal machine, it's probably fine, but is there a way that we can make also users happy? I know we don't think about users, but let's try. Well, there is. The answer is we embed the Python runtime into an Android app. Let this sink in, right? So like you remember the whole Termux part I was talking about, right? With the web server running, installing Python in there, can be summarized by using something called Chaquopy. Chaquopy is the library that integrates the nativeness of Python because it's using the Python runtime in our Android app. Okay, so this is now just going through, right? Again, go to chaco.com. I hope I'm pronouncing it well. If not, please let me know in the comments. And it just does the NDK part. So it takes the Python SDK, compiles it natively with the NDK parts, and puts it into your Android app. You obviously need to define this as a plugin, but I mean, it's nothing complicated. You know, you don't need to compile it yourself. You have to set the version numbers as you would do in your versions TOML, and you have to define that you actually want to use the plugin in your build Gradle files. You might also want to configure it, right? So like this is then just inside the build Gradle script, the configuration you would need. And the keen-eyed people under you see that there is something called pip in my Android app configuration. So you can feel my excitement, I hope. I can just install random libraries in Python in my Android app. Like this is a specific example I hope I have the time to go through in a bit. Where I just like use a library that does not exist somewhere else. So in this case, I could also, I would install the Fraktur library in here, right? So like if it's on pip, I can install it asterisk, like always. I can also define the version that I want to use in Python, right? So obviously it's only 3 and up, but it should. And I decided just in this configuration that it is the 3.13. Well, you're probably anticipating how this works. But now, how do I replace my backend that's running on Termux with the actual native runtime inside Android? Well, I start again with like the service, right? Remember where we had the backend service before? Now I'm just having like a field, a class, which is calling the Python backend. I lazily initialize the Python environment. So every time when I execute or like targets the Python variable the first time, it will check whether the Python environment is running already. If it's not, it starts it. And if it is running, it just returns the static instance I have. Perfect. But then I also need to do things like, okay, I want to now import module as in Python, but in Kotlin, right? And I do this by asking the Python environment, please give me the module with the arbitrary name I have decided. In this case, in the line 4, please give me the module called Fraktur. And then I have my Fraktur module in Kotlin that is a Python module. I'm getting very excited again. Because the next step is I can now, when I have the handle to the module, execute its methods. So I can call fraktur.generate, give it parameters, and I get a result back. And the nice thing about the result, this is a Py object, but I can translate it easily to Kotlin or Java classes. So in this case, I say result.toString to return me a Kotlin string based on the result I got from Python. Well, the last thing to be done is returning it into the calling environment so that we can adhere to our list of strings we want to get out when we put in a random message. And now it's demo time again. So just to be sure that I'm like not having something happening behind the curtain, let's go back to the terminal. So I'm opening the terminal. You see there's something opening here. I just don't want this. The server is still running, right? So this is the server output. You see that we made like 2 requests to it, one through curl, one through the old style of the app. But I'm just going to close this. So server is dead. No more server. Now Termux is dead. No more Termux. You can see. But for the sake of the argument, now I'm opening Fraktur, and I just want to say, hey, please work again on the website. It says like, okay, the web server is dead. Again, proof, hopefully, trust me, that the server does not run anymore. So the only thing I have is up here the option to click on the snake. This is my identifier to which backend do I use. Do I use the Termux web server backend, or do I use the native runtime of Python? And now we're gonna go here and say native runtime. So I'm not asking anyone right now, but you can try it out on your own time. Also, let's add some question marks because, okay, who's excited? Okay, so what does this mean, right? So there is no terminal involved anymore. There is no Flask server anymore involved. It's just directly running natively. It is natively translated to Python, then translated back, but all in one app. I can give you this APK and you can run it yourself so that we can make the users happy. So that is the result, right? You might be asking yourself in the last 5 minutes I have, why? Again, don't ask those questions way too often with the things I do, but like remember my introductory statement, right? There might be libraries that only exist on Python. For me, concretely, there was a library that translated random vector drawings into something my embroidery machine understands. So this is a Python library that does not, that tried to translate it into like Kotlin and Java, but it failed. Like this library is not existing outside of the Python infrastructure. So like it's very tiny there. Imagine you have seen a sewing machine, but this one is smarter and like you can actually embroider things on it and make the color work wherever it should. I found no other way. And I was getting frustrated because like the Termux thing is nothing I can give to somebody else. But with Chaquopy, I just say install the thing, and you can on your app now, on your phone now have an app where you draw things and then tell the embroidery machine, please embroider now. That was my motivation. We are going 4 minutes, great. Again, remember the almost not readable journey we have been through, right? I've been talking about Termux, like a UI or a terminal UI you should install if you're having fun exploring things by typing it. Then we also talked about web servers on Python, on Termux, where you can execute also native Android UI by using a web server running on your phone. Maybe there are other use cases you can think of where like maybe the web server native Android app communication is very important for you. But then we found Chaquopy. Chaquopy, embedding your Python runtime natively into Android. I hope that this is the thing you're taking away. It's very nice, very important, and I'm not affiliated. I just found this library randomly and I'm super happy with it. And with that one, I obviously have to show you at least one QR code. That is the QR code to my GitHub repository where this slides are actually hosted, but also where the Android code is hosted. If you want to find me, my name is Mario Bodemann on all of the social medias you can find except for X. And I'm happy for any questions you might have. Thank you.